Okay, welcome to this video for Chem 161, contributing to Chapter 4 content, here looking at the naming of covalent molecules. Up until this point, we've spent a lot of time understanding ionic compounds. So just as a quick comparison, in ionic compounds, we know that there are charge that is different between the two materials that are coming together to make the structure. So that is, we'll have cations and anions, and we have attraction between negative sites and positive sites, anions and cations, and we call this electrostatic attraction. Okay. It is something that brings ions together and bonds ions in 3 dimensions. So these structures tend to be quite extended. For example, each sodium ion in sodium chloride is surrounded by 6 chloride atoms, top, left, and right, and front and back. Okay. And while the formula says that it is a 1-to-1 balance, the balance comes from understanding that this pattern has to continue for sodium in all 3 directions thereafter on each chloride ion that I'm about to list here. Okay, so when we only take a look at one cation of sodium, it appears that the formula of NaCl is not reflected in that, but let's recall that this pattern has to extend in 3 dimensions further, with now each chloride having the same situation for sodium neighbors nearby. Okay, so that is how we establish the 1-to-1 ratio ultimately. Okay, so that's an ionic compound, and we see a lot of bonding surrounding each cation by electrostatic attraction. In covalent bonding, we have more of a sharing of electrons to establish the bond. Okay, so for example, 2 hydrogen atoms that are separated from one another will come together, and I've purposely drawn these as we recall that an isolated hydrogen atom is 1s1, as is the other 1s1, and when they come together we establish a bit of a football type molecule where those 2 orbitals overlap and constructively interfere and merge to give us orbital as such. And here now the orbitals, the 1s orbital that had a single electron for its characteristic, its wave, its population of electrons in there, we now have a 2-electron molecular orbital. Okay. And that 2-electron molecular orbital allows each hydrogen to appear as the next nearest larger noble gas, in this case helium, and appear to have a duet because there are 2 electrons in that shared 2-electron bond. Okay, so this is how we understand covalent bonding, and that idea applies for more complex structures than even just hydrogen, where we have multiple bonding and etc. But covalent bonds, sharing of electrons, is the key idea there. Ionic bonds, to contrast, electrostatic attraction of discrete charges on ions. Okay, so for covalent molecules, what we'll see for our naming exercise is that we'll be responsible for naming 2 or more nonmetals. Okay. two or more nonmetals is what can occur to generate covalent molecules. So you may be responsible for recognizing that, picking from a list those that are covalent molecules versus ionic molecules. But for naming, we'll be responsible for only covalent compounds that have two nonmetals. Okay, so recall your periodic table and our metalloid staircase boundary, and metals to the right of that are nonmetals. Okay, so you've got to turn to the periodic table to help you recognize a covalent compound from an ionic compound, and this is vital to not only picking the right compound, name ionic versus covalent, but also vital to applying the correct naming rules. Okay. Since we have compounds here with two nonmetals and we're sharing electrons, we won't be dealing with ions. So in covalent compounds, there are no ions. Okay, which means that there are no charges to balance. Okay. So in sodium chloride, we had to provide the correct number of sodium ions for the correct number of chloride ions in the formula to reflect an overall neutralization of positive charges with negative charges. Okay, so rewind to your notes on ionic compounds to see that point. But in covalent compounds, we don't have charges because we're sharing electrons, and so we don't have that duty for us. The subscripts come about from other rules that must be satisfied to achieve ideas for proper sharing, to achieve things like duets and octets throughout the structure. Okay, and we'll learn that more when we cover Lewis structures. Okay, so what we're going to see is, therefore, we're going to see multiple combinations between the same elements. Okay, between same elements that are these nonmetals. Okay, if you glance down to the bottom where we'll do some examples here, you can see here that we'll deal with things like 5 phosphorus atoms and 2 oxygen atoms establishing some structure. And we've got clearly multiple of the same elements involved there. And so we'll see that in covalent molecules. Okay, all the bonding within that must be covalent because both phosphorus and oxygen are found in the nonmetals area of the periodic table. Okay, so let's start with some rules to guide us. So to do proper naming, we mentioned you must identify the correct type of structure. Okay, so ID for correct naming rules. So this means answering the question, is it ionic or covalent? Okay, so again, recognizing elements within the compound molecular formula and finding those in the right spot in the periodic table is imperative to applying the right naming rules. Okay, the second thing we're going to need to use prefixes to tell how many of each element we have in the molecule. All right. So we see that in the molecular formulas down below. We clearly have some subscripts that are sometimes 1, sometimes as high as 5. We're going to need prefixes for that. Okay. So let's go over and look at a table that we must memorize, table 4.4 from your textbook. We'll see that we have prefixes, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Many of these you've seen in geometry. And of course, the subscripts that we might use for these are varying from 1 through to 10. So 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 might be a new one for you, 7 hepta, notice the P, 8 octa, we've got 9 for nona, and then we've got 10 for deca, okay? So again, you need to be very comfortable and memorize these prefixes to reflect information that we need in our covalent compound name per the subscript in that formula. Okay, so spend some time on 4.4 as needed. Okay, a follow-up on 2. Okay, so we'll call it step 3 here. Is that we are not, so do not use prefixes. Do not use a prefix if there's only one of the first element in the formula. Okay, so let's look at an example to do that in a moment. We'll just list briefly here our last rule here is that the second element, remember we said we'll be naming with 2 nonmetals. Okay, so the second element we expect to put attention to. We will apply what we've seen before. We're going to apply the suffix, the ending, "ide," to help with the naming. Okay, good. So let's look at some of these examples. We'll look at carbon monoxide briefly. So we know carbon monoxide, CO, is the formula. C1O1 is how we interpret that. So the word here would be, we have 1 carbon, so we're not going to use mono on carbon, so this is going to be carbon. And then we have to reflect the oxygen element present as the second nonmetal. Okay, so clearly this is 2 nonmetals for this compound. We're not going to say oxygen because we have to convert that into a word with the terminus that is "ide." So we're going to use "ide" there. In the second element, we are allowed to use prefixes to denote the balance, the number of these oxygen atoms. So here's where we're going to use our prefix. So we're going to go mono. Okay, and if I list oxide, I would have 2 vowels next. So when we encounter situations like that, one of the vowels is typically dropped. Okay, and so choosing that is a bit of an exercise in memorization, but we'll be quite flexible on that. So please identify chances there where you think you've got it right and it hasn't been reflected in an exercise like homework. But look carefully at options there. So monoxide would be incorrect. We're going to avoid the double vowel there and just go monoxide here for carbon monoxide. Okay. Another example there could be CO2, a cousin molecule there. You see we've got subscript 2 on the oxygen. And so the naming here, we're not going to use a prefix on the first element. So we're not going to say monocarbon something or other. That's incorrect. On the first element, we don't put prefixes. So carbon. And now we have to reflect the 2 somehow on the oxide. So we're going to apply dioxide. Okay. We are keeping the di complete, and we are keeping the oxide complete here because we can't lose a vowel there on the I and the O. Doxide is not the same as dioxide. Okay. All right. So be a little bit careful there. Sometimes you can check into your textbook to see what terms are there. So you might want to look at examples and start observing the patterns for how to handle vowels in the second name. Okay, some additional examples are down below. So this is a point where you might pause the video and try the 3 that we see listed here, and apply the naming rules that we've just learned here, and then resume the video to check your work. Okay, so the first one, NO sub 3, NO3. Okay, so clearly we're dealing with 2 nonmetals, nitrogen and oxygen. We see them side by side here in the periodic table. That's good. So let's start with nitrogen. Okay, not mononitrogen. That would be incorrect. Nitrogen. And now we need to reflect the 3 information for the 3 oxygens. So you can see here where you're going to use the tri. So nitrogen tri oxide is the correct name. We can't go troxide. We have to have the I to reflect the proper prefix information, trioxide. So this is correct. Okay, next we have N2O3. Okay, so we need to work with nitrogen again. Now we'll look at our rules, and it says we don't use prefixes in the first element if the number is 1, but here we have 2, so we do need di at this point, dinitrogen. Now we can apply the same ending for the previous example. 3 oxygens has to be reflected with the word trioxide, and you see the "ide" suffix applied here on the oxygen. Okay, perhaps a more intimidating example up front, but it's not so bad. We have 5 phosphorus. So again, we're going to call this penta, apply the prefix penta. Okay, now we apply the full name of the element, phosphorus. Okay, phosphorus. So we've been applying the full name of the element from the periodic table and applying a prefix ahead of that for the first word. And then we have to now apply a prefix for the 2 on the oxygen. So we'll be using di here and applying the "ide" terminus to the oxygen, so dioxide there, and our prefix of di is indicating 2. Pentaphosphorus dioxide, okay? So that is how we name covalent molecules, and we'll look at